I want to take 32, and I want to write it as two entities. There's a perfect square in 32. You say, I'm not sure what. Well, go down the divisors, go down the squares. Then you'd say to yourself, well, 1 divides 32, but 1 divides everything. 4 divides 32, that gives me 8. But is that the biggest square that divides 32? 9 doesn't divide 32. 16 divides 32. It's 16 times 2. So the next one is 25, so I'm done. 16 is the square that's in 32. So I know that the perfect square in 32 is 6. But to make it 32, what would be left over is 2. We're not quite there yet. Yeah. And then I go to the variable. In order to have a square where the variable is concerned, I have to have at least 2 of them. I only have 1 of them, right? So that means that I can write 32x as 16, that's the perfect square, times 2x. 16 times 2x is 32x. The perfect square in 72. Well, the perfect square in 72, if I go down my list of squares, I want the biggest number that divides 72. Well, you know it's not 81. You know it's not 64. You know it's not 49. 36. It's 36 times 2. So start with the biggest number that's closest to 72. You know it's not 81, and then go backwards. You'll get the biggest one that way. So it's going to be 36. Numbers are going to be the hardest. 36, and 36 times 2 is 72. The square that's in x cubed, the biggest square that's in x cubed is x squared. I've got 3 of them. 2 of them are the square, and that means I have 1 left over. X squared times x is x cubed. The biggest square that's in y to the 4th is itself y to the 4th. See, we're looking for the biggest even power. So this would be y to the 4th. That says if I multiply these two together, I get 72 x cubed y to the 4th, with the perfect square being 36, because the square root of 36 is 6. X squared, the square root of x squared is x. Y to the 4th, the square root of y to the 4th is y squared. I come over here. Can't take the square root of 2 or the square root of x. Neither one of them are squares. Well, what's the perfect square in 40? Well, it's not 49, it's not 36, it's not 25, it's not 16, it's not 9, because none of these numbers divide 40. It's 4. 4 times what? 10. Now the square in x cubed, well, the biggest even number before 3 is what? 2. And since I have 3 of them, I have 1 left over. Y to the 8th is even, so that says he is a square. Z to the 9th. What's the biggest even number before 9? 8. So it's Z to the 8 with 1 Z left over. Now I could take the square root of 4, which is 2, the square root of x squared, which is x, square root of y to the 8th, which is y to the 4th, the square root of z to the 8th with a z to the 4th. I come over here, 10 doesn't have a square in him, x is not a square in him, z is not the square, that's the leftover.
So in this one you said to take the biggest number that it can be squared, right? Or how would you say that?
Well, I look to see, since I'm doing square roots, I'm looking for numbers divisible by 2.
Okay.
And since I'm looking for a number divisible by 2, it's got to be even. So I'm looking for the largest even
If I were
number.
doing this, I would probably want to do the 10 over, but because because it's a perfect square, it has to be.
Has to be a perfect square. So in other words, what it has to be is in this list.
Oh, okay.
If it's not in that list, then it's not a perfect square. So all of these numbers here would be in that list. But I need the biggest such number. So that's why I'll start from the bottom and work my way up. Use your calculator if you need to do some division to find the largest square. You've got your table, just kind of work your way back up until you get the largest number that divides that. Because it's harder from the top down, because like in 36, 4 divides 36, but 4 divides 72, but 36 is the actual square, not 4. So start with the bigger one, closest to 72, and then look for the biggest number that divides that. Because you're looking for squares, you're looking at the square column. The more that you do of these, when you start practicing them, the easier it will be. The numbers are the hard part. The letters are going to be the easy part. Perfect cubes. Now, I want to find the largest perfect cube and the leftovers. Now I'm using the table that has got the cubes in it. So in other words, that number has to be in the list. These are the perfect cubes. The perfect cube that is in 48. Well, I need a number that divides 48 that's a cube. 27 doesn't. 64 is too big. 27 doesn't. 8 does. So 8 is the cube that is in 48. And what do I multiply 8 by to get 48? 6. Now I need multiples of 3 for the variables. Remember, I'm going to be taking the index, which is 3, dividing it into the exponent. So I'm looking for now numbers that are exponents that are divisible by 3. I have to have 3 of each letter in order to take 1 out. For every 3, I can remove 1. So there's only 1 x, so it is. And if I multiply these two together, I should get that. 56, even I don't know 56. 56, 64, 27. 27, though it doesn't divide 56, looks like it's going to be 8 again. So the perfect cube is 8. Now, what is the biggest number divisible by 3 before 7? 3, 6, and the next one would be 9, because I'm looking for multiples of 3. So it would be 6. So it would be x to the 6. I've got 7 of them. There's an x left over. What do I multiply 8 by to get 56? 7. Now, here's this guy. Negative 72. Well, now I'm looking for the multiples of, now it's going to be a negative number because I can have negatives for negative 1 times negative 1 times negative 1 is negative. Now, it's 72. Well, 64 doesn't divide 72. Does 27? No. Take your calculator. Does 27? No. Does 8? Yeah. So it's 8. What do I multiply 8 by to get 72? 9. Now I'm looking for multiples of 3. In x to the 7th, what's the largest multiple of 3? 6. I have 7 of them, so there's 1 left. 6, this is 3 divides 6, so I'm home free. Z to the 5th, what's the largest multiple of 3? Z to the 3. And I have 3 of them. I have 5 originally. How many's left over? 2.
Wait, why did you put 3 for Z? What did you put 4?
Well, remember, we're doing cubes. Cubes are multiples of 3 instead of multiples of 2. This is the hardest part.